In this first video, in the first section in our pre-calculus course, we're going to take a step back before we start taking a look at functions, and we're going to look at some fundamental graphing in mathematics. And so what we're going to do is we're going to start by taking a look at sets of numbers, and we're going to be able to plot those numbers on a number line and on a Cartesian plane. We're going to be able to substitute values into an algebraic statement and then be able to evaluate. We're going to graph equations in two variables on a Cartesian plane, and then we're going to be able to identify the intercepts from the graphs. At the core of mathematics are sets of numbers, and at the hierarchy of most of the numbers that we're going to study in this class are real numbers. So real numbers are essentially any number that we use in everyday life, right? So if you go to the grocery store and you pay money, or if you measure the distance with which you're walking to the store or something of that nature, then that would be a real number. Below real numbers are two sets of numbers. We have these things called rational and we have irrational numbers. And rational numbers are going to be the numbers that can be expressed as a fraction, essentially in lowest terms. So for instance, rational numbers could be something like 5, because 5 can be written as 5 over 1, or something like negative 2/3, or even something like 0.33333, because that could be written as 1/3. Okay, so again, any number that can be written as a quotient of two integers, or basically going to be a fraction in lowest terms, that's a real number. Now, irrational numbers, those are the ones that we don't necessarily use all the time, but they do occur in mathematics. So like square root of 2, pi. Some of you might have seen the natural exponential base e before. All right. And if you haven't seen that, we're going to study those in the class a little bit more. All right. But those are all your irrational numbers. And below the rational numbers are three sets. We have integers. And integers are either positive or negative whole numbers. So that's like something like 17, negative 2, 13, even 0 is an integer as well. Below integers are whole numbers, and whole numbers start at 0 and they just keep going up infinitesimally by 1. All right, so that's the set of whole numbers. And then finally, we have these natural numbers, which is basically the set of whole numbers, except we omit 0. So it just starts at 1 instead of 0. All right, so those are our sets of numbers. Now, our job in this course is to be able to plot those numbers, and we can plot them in a few ways, one of which is going to be on a number line. Okay, and then once we start looking at bivariate data, then we can plot it on a Cartesian plane. But number line is basically going to be the way that we geometrically represent numbers. And you probably remember that with a number line, it's just a line in the middle. It's bisected by 0. And we know that we have units on the number line. All right, so I'm just going to say that this is 1, this is 2, this is 3, 4, and 5. And anything after that is going to be a positive value. So anything to the right of 0 is positive. And then, as you all know, anything to the left is going to be a negative value. Right. And so if I wanted to plot a value on the number line, such as -5, what I would do is I would just move to the left 5 units and I would just put a dot right there at -5, all right, or about that. And again, it's a little bit tough for me because on my computer screen, it's a little tough to draw, so excuse the sloppiness on occasion, right? 4.3, we know that that number is going to be a little bit more than 4, right? And so what we could do is we could zoom in a little bit, and 4.3 is going to be more towards 4 than 5. So I'm going to plot it like right about here on our number line. And then finally, 7.6. Well, 7.6 is going to be a little bit more than 1. We could certainly go into a graphing calculator, and we could just type 7 divide 6, and then hit enter. And that's going to give us like 1.16. So we're a little bit to the right of 1 when we're graphing it. And so when we graph 7.6, that's going to be right about here approximately. All right, so that's how we plot some numbers on a number line. I'm sure many of you have done this many times, just reminding folks that haven't seen it in a little while how to do so. Now, substituting into an algebraic statement. Algebraic statements are comprised of terms. So terms are separated by plus and minus signs. So right here in this expression, x squared plus 17, this has two terms, and the two terms are x squared and then 17. 17 is a constant, and x is a variable that's being raised to the second power. All right, so I'm just going back, kind of dissecting these algebraic expressions before we move on and do a little bit more with these. So what we're going to do is we're basically going to evaluate these expressions at given values. All right, and so if we want to do that, we're just going to substitute. So we're just going to take 12 and we're going to substitute it everywhere we see an x. And so this is going to become, whenever I substitute things, I put it in parentheses. All right, so this is going to be 12 squared plus 17. And then we just use the order of operations. So remember, in the order of operations, we have PEMDAS, and P stands for parentheses. All right, we really have a 12 inside the parentheses. It's just a number. But then we also have exponents. And so 12 squared is going to be 12 times 12, which is going to be 144. And so this expression now becomes 144 plus 17. And we know that 144 plus 17 is going to be 161. All right, now, of course, we could shove that into our calculator as well. So we could do parentheses 12. We could close the parenthesis, and then we could square it. And then we could add 17. And that gives us 161. All right, we would just hit enter on our graphing calculator if we have like a TI or something like that. All right. Same thing down here. If we substitute -2 back in, we want to make sure we use parentheses. And we're going to substitute it everywhere that we see an x. So this is going to be 2 parentheses -2 squared minus 3 times -2 minus 8. Again, our order of operations tells us to be able to square or to be able to do exponents first. So this is going to be 2 parentheses 4, since -2 times -2 is 4, minus 3 times -2 minus 8. Now we're going to multiply. So we have 2 times 4, which is 8. We have -3 times -2, which is a 6. We have minus 8. And then finally, we work from left to right. This is going to be 14 minus 8, which is going to be 6. All right. And again, we can always shove that into our calculator. Right. So just going back into our device, we have 2 parentheses -2. All right. Now, on a graphing calculator, there's going to be a negative sign and there's also going to be a minus sign. I think on this one, it looks like that you just use the minus. So I'm going to give this a try and see if it just works like that. I'm going to square it, and then -3 parentheses -2, close parenthesis, and then finally -8, and then we hit enter, and it gives us 6, which is the same thing that we got before by doing it by hand. Certainly, we want to make sure that we know how to do this by hand, but it's certainly more efficient if we utilize our calculator. So that's all that we're going to do with the number line and graphing with algebraic expressions. So in the next video, what we're going to do is we're going to take a look at the Cartesian plane, which is going to be bivariate data or two-dimensional data. And we're going to go ahead and plot that. And then we're also going to start taking a look at how we graph these sorts of relationships in two variables.